Okay, we're going to cover today the last continuous distribution, that is the uniform distribution. And I think the uniform distribution is the easiest distribution of all the continuous distributions. Up to now, we covered the normal distribution, which is a bell-shaped symmetrical distribution where the majority of the values are in the middle, right? The majority of the values are in the middle. We also covered the exponential distribution that goes from 0 to infinite, where the majority of the values are, close to 0, right? In the normal distribution, the majority is in the middle. In the exponential distribution, the majority of the values are, closer to 0. The uniform distribution, it has this shape. So the values are uniformly distributed between a particular interval A and B. That's it. This is the uniform distribution. All the values are uniformly distributed in an interval A and B. Now, we know that the area over here has to be equal to what? To 1, right? So the height of the distribution, in order for this to be equal to 1, this has to be 1 divided by b minus a. Okay? So f of x, this is f of x, is equal to 1 divided by b minus a in an interval, in the interval a and b. And that's it. The mean is equal to a plus b divided by 2, and the standard deviation is equal to b minus a divided by the square root of 12. It has to be in your teaching, because I'm going to ask you what is the standard deviation or the variance or both. And again, if I ask what is the probability that x is equal to n, equal to 0, we have to deal with less or equal, greater or equal, or an interval. Yes?
Is that a 2 as well?
It's a 2. A plus b divided by 2, and b minus a divided by the square root of 12. 12. All these formulas are in your book, so you can verify that. That's it. Let's do an example. Let's say that whatever it is, let's say your cable. The cable charges in Americas are uniformly distributed, okay? Uniformly distributed between $20 and $120. Okay? So let's say that the charges for cable companies in America are uniformly distributed between $20 and $120. So this is A and this is B. So I know that this is 20 and this is 120. Okay? So how many elements do we have over here? How many numbers? I mean, what is the length of that interval? 120 divided by minus 20. Over here we have 100. in order for this to be 1, this one has to be what? 1 divided by 100. Right? 1 divided by b minus a. So this is a, and this is b. So a and b are the interval, are the values of the interval in my uniform distribution, a and b. So the distribution is between a and b. A is 20, b is 120. So what has to be the height of the distribution? The height of the distribution has to be 1 divided by b minus a, and 1 divided by 120 minus 20 is 100, so 1 divided by 100. And that's it. So if I ask you, what is the probability that your bill is equal to 35? What is that probability? 0. Yeah. What is the probability that x is greater or equal than 35? Okay, so 35 is right here, and I'm looking for this probability. Remember, probabilities are measured in areas. So what is the probability? So we have to know what is this width of the rectangle, okay? How much is this rectangle? Is 85, right? Divided by what? By 100. So it's 0.85. The probability that your bill is more than $35 is 0.85. Right? Remember, how do you get the area on a rectangle? Is the base times the height. What is the base on this and this one? Okay? This one has a base of 85. 85 times 1 over 100. So it's 0.85. Okay? Now, what is, in the same example, what is the probability? I mean, I can ask you many things. What is the probability that your next bill is less or equal than 35? So you need to know how much is this one times this one. So it's 15 divided by 100, and this is 0.50. What is the probability that my bill is between 30 and 40? Okay? Okay, this is the probability, and I want 30 and 40. I'm looking for that probability. So I need to know what is the base. The base is 10 divided by 100 is equal to 0.1. You see? Right? Because whenever I want to know the probability, I need to know the area. And the area in any rectangle is the base times the height, and that's it. And the height is always 1 divided by 100. This is always divided by 100 in this problem. In another problem, it's going to be another thing. It's 1 divided by b minus a. Right? What is the probability that the next bill is greater than 130? The 130, guys, 130 is over here. There are no probabilities. There are no areas over here. The area is only in this interval. So it's 0. There are no areas. What is the probability that x is less than $15? 0. There are no areas below 15. These particular examples goes between 20 and 120. Okay, what does it mean? Is 140 divided by 2 is equal to 70? What is the standard deviation? Is 100 divided by the square root of 2. That's it.